Hello, space people. I wandered down another rabbit hole here, and I found it to be very interesting. I was looking at these fabulous photographs of the James Webb Space Telescope. They're all over the internet, all over YouTube. It's just absolutely beautiful and amazing. The things they're learning from this new telescope. And I asked myself this question: where is the James Webb Space Telescope? And the answer came back: it's at Lagrange point 2. I said, okay. I've heard of Lagrange from math and physics, but I didn't know he had any points. So what's a Lagrange point? That led me down another rabbit hole. And that rabbit hole is this. This is the sun, the earth, and the moon. And if you take all of this, the gravity, the points, so you treat the earth and the moon as a center mass, so that's one, the massive object. The sun is a massive object. You work out the newtons, the force of gravity for this system, assuming there's a satellite which has a very small mass that can be ignored compared to these two massive objects. It turns out there's 4 points. 1, 2, 3, 4, 5. And these points are called Lagrange points. And what they do is they rotate around the sun at the period as the earth. So what that means is if you put something there, a satellite, that satellite will stay with the earth as it goes around the sun. And so I kept reading and I said, okay, I want to understand this. So I looked up the equations, I wrote them down, and it turns out they can't be solved uniquely because it's too hard. You come up with a fifth the power equation. So you have to solve it uniquely, and numerically, so I lost interest in that. But then I read that the orbit of L1, L2, and L3, these linear ones, is unstable. And I said, well, why are they unstable? Well, that took me down the rabbit hole. And here's the best way I can understand it, is that here you have the Earth and the Moon, and here's the James Webb Space Telescope at L2. And if you think of these as gravity wells, so now we're back to space-time. So that's the gravity well of the Earth, the gravity well of the Moon. You see that this L2 and L1 are sitting on these saddle points. And what that means is like trying to balance a marble on top of a watermelon. It's just extremely hard to do. So they brought it to here and put it in an orbit around right before L2, such that it used the minimum amount of energy to do a course correction, because otherwise it would keep wandering off this way or that way or both. So they parked it here and did that. And this shows, where am I? The orbit. So you can, here's the Earth, there's the sun obviously. You can see it going around L2. It's absolutely amazing. And you wonder how far away is it? It is 1.5 million kilometers from the Earth, the telescope. And there's how far the moon is. So it's much further than the moon. Now think about the technology that we have that can do this. We launch a rocket, okay? The rocket's taking off, she's going. Now this is moving. This is moving around the sun. And this is moving around the Earth. And this is moving out to find some place to park 1.5 million kilometers away while all of this dynamics is going on. I find that absolutely amazing. This stuff blows my mind. I love it. All right. I'll see you later.